Hello again. So with differential equations, we're going to do probably three different general ways of looking at them. One, we're going to look at the equations. Two, we're going to look at the graphs. That'll be a slope field. Three, we can look at a table of values or estimations using Euler's method. But we're going to start off with the most basic and the most useful, and that is just solving differential equations. And it's really simple. You can see two steps on the board over there. All you have to do is split up the x's and the y's. Put all the x's on one side, put all the y's on the other side of an equation, and then integrate both sides. It could be that easy if it's an easy enough equation. So for instance, for this problem right here, rewriting this so that all the x's are on one side and all the y's are on the other is not really much of a problem. Honestly, we were just cross-multiplying there. And then integrating, that also is not a big deal. Dun, dun, dun. And bada bing, you've got an equation here. Yay, it's an equation because it has an equal sign. That's what the equation thing means. Okay, don't be scared if it's still written implicitly. For the AP exam, most of the time they're going to ask you to solve for just plain old y. They might not give you one that looks like this. This would require a little bit of work, which we're not going to go into the algebra there. But they could be written implicitly. The second thing is, I don't want you to worry about putting a c on both sides of the equation when you integrate. Because all I'm going to do, if this is the constant number 1 and this is a constant number 2, is I'm going to subtract constant 1 from the left side. I'm going to move that over to the right side, c1 minus c1, and then this constant minus that constant just makes yet another constant. You can save a whole lot of time if you just put the constant on one side. You don't need it on both, because we know no matter what happens in the end, there will be a constant. By the way, with that plus c, that means that this is a general solution. Yes, folks, that means it ranks above a major, maybe below an admiral. I don't know how all that works. It's called a general solution because with the plus c, it represents a whole family of different equations. But now for our second example, now we've introduced something different. We have some sort of initial condition. It's just like when we're integrating to find a function earlier in the year. It's the same thing. What we want to do is we're going to solve for c once we get it. So here, take my advice on this. First thing first, if you've got a y prime, it might behoove you, I just like using that word, to write it as dy over dx so you can think about, hey, how am I going to separate those variables? Second, what I want you to do is I want you to figure out which side of that equal sign am I going to put all my x's and which side am I going to put all the y's. If dx is in the denominator here, I'm going to have to multiply it across. We never take an integral of something divided by dx. No, we want dx up in the numerator or just as a value unto itself. So I look at this and I see dx in a denominator and I realize at some point I'm going to multiply it across to the other side. My x's should be on the right. So in doing that, I will take the square root of y. I will move the x value over there. Then I will multiply both sides by dx. I hope you caught that. And then I'll integrate. It should look something like this when you're done. But please don't forget that the c that was on the left, I subtracted that constant over to the right-hand side. So we'll just have one constant here. But here's the final step. If we want to find a particular solution, one solution that goes through just that point. Because even though we could have an infinite number of values here for c, only one of them will go through this point at 1, 9. So that's right, folks. Just like with a normal integral, we'll plug in both 1 and 9 for the x and y. And once you plug those in and solve for c, now you can write out the actual final equation, no longer with c, but with whatever you like, whether you like 18 2/3, 18.666 repeating, whether you like the other one. And once again, the AP exam may come through and say, hey, look, we really want you to solve for y here. Hey, it's a little bit mathy, but once you had this result, and I did switch that to 54/3 because it would make it easier. To solve for y, I'm going to multiply every single term by 3. Then I'm going to divide every term